All right, so last time we talked about quadrant 1 of the unit circle. Now we're going to talk about quadrant 2, 3, and 4. Okay, so we only talked about quadrant 1 because it was new, but now that you're going to start seeing some patterns with each quadrant, and when you see those patterns, it's going to make your job a lot easier. So that's why we're going to do the rest of them today. All right, so this is quadrant 2. So we did quadrant 1 before, and you can see the triangles because we're going to use similar triangles that we did last time. Congruent triangles, actually. So the next angle that we would measure, so this is 90, of course. This is 90 degrees right here, which is the same as pi over 2. Okay. And then we know this coordinate is 0, 1. So the next one would be right there. So that reference angle, or that angle measure, would be that right there. Okay, and then for that one, what we're going to do is we're going to use the blue. That fits right there. Okay. Well, this angle measure here is 120. Okay, so this is 120. Okay, because it's 90 plus another 30, which makes 120, which is the same as 2 pi over 3. Okay, so that means this reference angle here, if this is 180 down here, and this is 90 here, and I'm at 120, that means I have 60 left. So that's 60 degrees. Well, if that one's 60, that means that has to be 30, and obviously that one's going to be a right triangle. Okay, so now the coordinates. Where is this one listed? Well, this looks just like what we did in quadrant 1. In quadrant 1, we had a 30, 60, 90, right? Except it was just in quadrant 1. So now what we're going to do is we have the same sides. Obviously, this is still going to be 1 right here. This side is still going to be 1 because it's the radius of the circle. Okay, well, for 30, 60, 90, the short side, so the side opposite, is going to be 1/2. So this side here, this side right here is going to be 1/2 of the radius. So this is going to be 1/2. Okay. And then the side opposite of 60, this length here, is going to be the square root, is going to be 1/2 times the square root of 3. Okay, this is just based off the 30, 60, 90 notes from last week and from last time. Okay, so when you multiply those together, you're going to get the square root of 3 over 2. So that means the x is 1/2, and then I'm going to go up square root of 3 over 2 to get to the dot right here. Okay, so 1/2 square root of 3 over 2. Those are the coordinates for when we had a 60 degree. What's the difference here? Well, the difference here is we're in quadrant 2. So in quadrant 2, x's are negative, y's are still positive because we go in the negative direction. Because we went left, that means from 0, 0, it means the angle is going to be, negative 1/2. So that means x is going to be negative 1/2, y is going to be the square root of 3 over 2. Okay. Okay, so the next angle we're going to do is the middle in quadrant 2. So the first one was 120 or 2 pi over 3. The next one is going to be 135, which as radians is 3 pi over 4. Okay, so that one is going to match this triangle here. Well, 135 is right in the middle of 180, because 180 is down here, and 90, or pi over 2 and pi. Okay, so because it's right in the middle, it's going to be 45 degrees. That means this one will be 45 degrees as well. And of course, this is always 90. Okay, and again, we always know that 1 is the radius. So with a 45, 45, with a 45, 45, 90, we know that I have to divide the radius by the square root of 2. So 1, let me write that again. 1 divided by the square root of 2. Okay, and then to do that, I have to rationalize. So I have the square root of 2 over the square root of 4, which is also 2. Okay, so both sides are going to be the square root of 2 over 2. The square root of 2 over 2. Both lengths are the same because it's an isosceles triangle. 45, 45, 90s are isosceles triangles. Okay, so that means the coordinate here is going to be the square root of 2 over 2, comma, the square root of 2 over 2. Okay, that's for 135, which is 3 pi over 4. Okay, so the last angle that we're going to talk about in the second quadrant, so we have 90, we have 120, we have 135, and then the last one is going to be 150 degrees. Okay, so when you convert that to radians, you get 5 pi over 6. Okay, so the last thing we got to do in quadrant 2 is figure out what are the coordinates of this red dot here. How much do I have to go to the left, and how much do I have to go up? Oh, and I forgot, from the last video, from the last part, I forgot that's supposed to be negative because remember, the x is going in the left direction. We're going up still, so positive, so y is still positive, okay? In the second quadrant, x is negative, y is positive. Okay, in quadrant 1, they're both positive because we go to the right and then I go up. But in quadrant 2, that's opposite. Okay, so I have my triangle in there. So the reference angle here, by the reference angle, I mean this angle here, the angle that I have right there. The angle that from the angle measure back to the x-axis. Okay, so it's 150, this is 150, and then I have 180 over here, so that means this is going to be 30 degrees, so the reference angle is going to be 30. That means this is going to be 60. That means this is obviously 90 degrees. So again, we still have a 30, 60, 90. And we know that this guy is 1. Well, it looks a lot like this blue guy over here, just kind of rotated or reflected. That's essentially what it is. Okay, we know that the side opposite of 30 is going to be half of the radius. Okay, so I'm going up 1/2. And then we know that the side opposite of 60 is going to be the shorter side times the square root of 3, which is the square root of 3 over 2. Again, because I'm going left, because I'm in quadrant 2, it's going to be negative the square root of 3 divided by 2. Okay, just like in quadrant 3, which we're going to do in a second here. In quadrant 3, I'm going left and down. So they're both coordinates here. So every single coordinate here, here, and here are going to be negative. In quadrant 4, here, here, and here, right, so x is positive, down, left is negative. Okay, so before we go on to quadrant 3, I want to answer a couple questions that you're probably going to see. Okay, so now we bring in, so we have all of our coordinates. We know the angle measures for each of the spots, each of the dots in quadrant 2 of the unit circle. Now, how do we do sine? Well, you remember sine is opposite over hypotenuse, right? Okay, so first of all, we got to do is find the angle. That's the angle there. So that angle is right here. Okay, so we know that comes from a triangle that looks like this. We know that comes from a triangle that looks like that. Okay, and we actually have the coordinates. I have the coordinates right here. Okay, so sine is opposite. So this is always our starting angle. The angle in the center is always our starting angle. So opposite of this angle here, opposite is going to be this length here. That's the height. Well, the height is pi over 2, or sorry, square root of 2 over 2, divided by the hypotenuse. Or the hypotenuse on the unit circle is always going to be the radius, which is always going to be 1 on the unit circle. So anything divided by 1 stays the same. Okay, so sine of 3 pi over 4 or sine of 135, they mean the same thing, is going to be square root of 2 over 2. Okay, now cotangent. Cotangent, you can think of cotangent as one of two things. You can think of 1 over tangent, or since tangent is sine over cosine, you could think of cosine over sine, whichever way. Okay. So let me erase this. Let's just use 1 over tangent. So let me find tangent first. Okay. So 1 over tangent. So we know tangent. We know to do tangent, it's going to be opposite over adjacent. Well, 1 over tangent means it's just the reciprocal. So it's going to be adjacent over opposite. Okay, that's all that means. So that's what we're looking for here. Okay, so move that triangle out of the way. So 5 pi over 6. 5 pi over 6 is right here. So that triangle would look something like this. Try that one more time. Okay, so okay, so again, this is going to be the angle measure because it's always the center. So we're looking for adjacent over hypotenuse. Well, we know this is 1 here. And I know I'm going to go left negative square root 3 over 2 from right there. And I know I'm going to go up 1/2. Okay. So now it's adjacent. So adjacent to this right here is this side. So that's negative 3 over 2, square root of 3 over 2 divided by opposite, which is the height in this case. Okay. Well, if I'm dividing a fraction by a fraction, I can go keep the first one, change, multiply by the reciprocal of the second. Okay, so the 2's are going to cancel out, and you get the negative square root of